Hi everyone, today we will talk about parametric curves and surfaces. Let's think about the curve first. Let's say that this is the curve, this is given by c of t, like that. And since it is the curve in the plane, so there will be two coordinates, x and y, like this. And we want to find the tangent line at one point. So let's fix one point here. It means that it is c of t, so like that. And find the tangent plane at this point. It's not good. I think like this. Yes. Let's say that this this tangent line is L of S. We want to find the parametric equation of this tangent line, okay? Actually, we learned the equation of lines before, and I will show this. This one. Equation of lines is given by one point A and the direction vector, okay? So, as you can see here, if we know the direction vector and one point, then we can find the equation of this line. Okay, then parametric equation is given by one point plus our variable times the vector. Okay, and one thing we notice here is this vector, this black vector is c prime t0, exactly c prime t0, because it is the tangent vector to our curve. So this black vector is given by c prime t0. And as you can see, we know that there is a point c of t0 lies on L of S. So we can say that the parametric equation is given by one point c of t0 plus our variable s times our vector c prime. So as you can see here, parametric equation is given by c of t0 plus s times c prime t0. Okay, this is the parametric equation of the tangent line at one point. Okay, then let's think about the second case. In this case, we want to think about the parametric surface. So let's say this is the surface given by r of u comma v. And we think about the surface actually in R3. So there would be three coordinates. And these coordinates is parameterized by u and v, okay? And to fix one point, it means that let's fix one point, r, u0, and v0, okay? So we want to find the tangent plane at one point, r, u0, v0, okay? To find the equation of planes, let's think about just a minute. I will copy and paste what I learned before. This is the equation of planes. Actually, there are two types of equations. One is parametric equation, and the second thing is linear equation. Actually, here we want to find the parametric equation, and to do this, we want to find two vectors which lies on the plane, and we want to find one point on the plane. Then, as you can see here, we know at one point and we want to find the tangent plane at this point. So what you want to do is find two vectors lie on this tangent plane. Okay, then let's think about the, just I will let's think about this case. Our parametric surface, yellow surface, is given by RU and V. There are two variables. And if we fix one variable, then it'll be the curve because there is one variable. So one variable is just a curve. So let's think about the U curve, which is the curve. Um, this curve has only one variable u. So let's say that this is the u curve. It means that it has only one variable u, and then v must be fixed. Actually, this curve passed through this u0 comma v0, so our v must be v0. This is fixed v0. So along this curve R of u comma v0, since v0 is fixed, our variable is just the u. So it is called u curve. And as we see before, we can find the tangent vector of this, green curve. So this, which color is where? I think it's not good. Let's use the red. And this vector is the tangent vector, which is given by the tangent vector at the curve, tangent vector to the curve. So it is the exactly r prime u of v0, but we can calculate it using the partial derivative. Actually, when you take a partial derivative with respect to u, we, we regard v as a constant, right? Actually, this curve means we'll regard v as a fixed number. It means that we regard v as a constant. So this tangent vector is exactly t of u, tu. Um, so it is given by the partial derivative at each coordinates. So if our parametric surface is given by r of u comma v, then we can find the one tangent vector here by taking partial derivative with respect to u. In the same manner, we find the v curve, which is given by r0v. This is v curve, and there would be, tangent vector. This is tv. So this tangent vector is given by taking partial derivative with respect to v at each coordinate. Okay. Since we know these two vectors, you can see that I will copy and paste this one. We learned before. Um, if we know u and v and one point A, then our parametric equation was given by 1 point plus one variable s times one vector u, and the other variable times the other vector. Okay, so um, our parametric equation of the tangent plane would be given by 1 point here. This point was given by r of u0 comma v0. So this point plus, if we say there are two variables s and t, then s times this tu plus v times tv. Then it'll be the parametric equation of the tangent plane. So exactly what we obtained here if we said that this tangent plane is given by L of S and T, then this is the one point here, one point lies on the plane, tangent plane, and plus this is the our one variable S, and times, it is the TU U0 V0. Um, TU is our one vector lies on the tangent plane, and T is the other variable T, and times the other vector TV. So our parametric equation is given by like this. Um, but as you saw in this image, there is another type of equation. Actually, it is the linear equation of a plane. If we know the normal vector, then we can find the equation like this. So if we know the normal vector and one point, then we can find the um, equation of a plane. Actually, it is not a parametric equation, but sometimes it is very useful. So let's find the normal vector and find the linear equation of a plane. So in this case, since we know two vectors here, if we take cross product, then we can find the normal vector. So our normal vector is exactly given by TU cross product with TV. So this is the normal vector of our tangent plane, okay? And in this case, since we know that the R of U0 V0 is our one point, actually let's say that R of U0 V0 is exactly the point X of U0 V0, comma Y of U0 V0, and Z of U0 V0, okay? And for the convenience, let's say that it is X0, Y0, Z0. Just for the convenience, let's say that this point is x0, y0 is 0, then our equation of the tangent plane is given by n inner product with the x minus x0, comma y minus y0, comma z minus z0 equal to 0. So in this case, actually, we do not simplify in this case. Um, After we find the cross product, if you put here n, then you can find the equation and you can simplify the equation. So I think it's better to show this by solving some problem. Okay. So actually, a parametric equation of the tangent plane is given by this one, but there is also the linear equation of the tangent plane. These two equation gives the same tangent plane. Okay, so let's solve some problem here. In this problem, let's find an equation of the tangent to the curve at the point corresponding to the given value of the parameter. Okay, here there are two problems, but I will solve only one problem. The problem one here. X and Y are parameterized by parameter t. So if we think about the curve C of t, it'll be, t cubed plus 1 and t to the 4 plus t. It is given by like this. Then our c prime t is 3 times t squared and 4 times t cubed plus 1. Okay. We are interested in that point t equal to minus 1. So let's find the c prime minus 1 here. If we put this t equal to minus 1, it'll be 3 and minus 4 plus 1, so minus 3. Okay. And actually, we want to find the one point here, c of minus 1. It is if we put t equal to minus 1 to the c of t, then we get 0 and 0. Mhm. As you can see here, c of minus 1 here, and we know that c prime minus 1 here. So our equation of the tangent to the curve is given by our 1 point, fixed point, plus s times our c prime, 3 minus 3. So we can simplify it, 3s comma minus 3s. So our tangent plane is given by, tangent line at t equal to minus 1 is given by 3s comma minus 3s. Okay? Let's solve the problem 2. Our parametrization surface is given by function g like this. First of all, let's think about the surface. Um, let's draw a given surface here. So it'll be the surface in R3. And if V is fixed, then it is just the, V is fixed. It means that our height is fixed. So at each Z, we can think that this is 2 cosine u, and 2 sine u is the circle, right? So you can say that this is the circle lies on the xy plane, and the radius will be 2. If you are not familiar with this, let's say that this is x and this is y, then you get x squared plus y squared is 2 squared 4 times cosine squared u plus 4 times sine squared u. And it'll be 4 times cosine squared u plus sine squared u. And cosine squared plus sine squared is just the 1, so it'll be 4. So as you can see, this equation implies that it is the circle with the radius 2, and its center is 0. So if we think the point here, then it is like this. It is just a circle, and at its point, actually, it'll be circle like that. Because V does not affect X and Y here. So if we fix V, then it means that Z is fixed. So at its Z, we can see that this XY means just the circles. So if we fix Z, then there must be circles. Okay. And the Z is just the V. So it means that this equation implies that it is the cylinder like this. So this is the cylinder, and actually we draw the U curve and V curve. U curve means V is fixed, right? So if V is fixed, this curve, actually the circle is U curve, and our V curve is just a line like this, vertical line. Because if U is fixed, then X and Y are fixed, and this is Z where Z is changed, only Z is changed. And so XY is fixed and only Z height is changed. So it is V curve. So U curve and V curve, we find it. And then what you want to do is compute TU, TV, and find the normal vector here. So, tu was given by the partial derivative. So let's take partial derivative here. Then you get minus 2 sine u and 2 cosine u and 0. And TV is given by 0, 0, 1, right? Then n is the cross product with this 2 point. So it is ijk and minus 2 sine u, 2 cosine u, 0. And 0, 0, 1. Then you can say that it is 2 cosine u I and maybe minus plus 2 sine u j and 0. So it is our normal vector is given by like this. And then we want to find the equation of the tangent plane. Okay. Just a minute. So we find the do we have, yes, we have one more page here. So we want to find the equation of the tangent plane. So let's find the equation of the tangent plane. And since we have normal vector, actually here, we have normal vector 2 cosine u, 2 sine u. We can find the linear equation of the tangent plane, okay? Linear equation of the tangent plane. And to do this, we want to find the given point. So let's find the point, one point here. By putting x equal to pi over 4, u equal to pi over 4 and v equal to 5. So we get 2 cosine pi over 4, 2 sine pi over 4, and 5. It'll be, 2 of root 2 over 2, 2 times root 2 over 2, and it is 5. So our point is root 2, and 5. Okay, since we know one point and the normal vector, we find the linear equation of the tangent plane. So it'll be given by n in a product with the x minus 1 root 2, y minus root 2, and z minus 5 equal to 0. Since our normal vector is given by 2 cosine u, 2 sine u, and 0, if we take a inner product here, then we get x minus root 2 times, I think it'll be better to find the normal vector at our given point here. So, our normal vector is given by like this, but we want to find the one normal vector at a fixed point. So we can find the normal vector by putting this u equal to pi over 4 and v equal to 5, but there is no v. So our normal vector is given by 2 cosine pi over 4i plus 2 sine pi over 4j. And it is, root 2i and root 2j. And there is no k component, it'll be 0. Okay, so our normal vector is root 2, root 2, 0. I think it is better to write again. Okay. Okay. So we want to find the linear equation of the tangent plane at one point here. Since we know the point is given by root 2, root 2, 5. X minus root 2, x minus root 2, sorry, y minus root 2, and z minus root 2. And here normal vector is root 2, 0. It'll be 0. Okay, this is the linear equation of the plane. So let's calculate the dot product, inner product here. Then root 2, x minus root 2 plus root 2, y minus root 2 plus 0 equal to 0. So we can simplify this one by dividing by root 2. We get x minus root 2 plus y minus root 2 equal to 0. So it means that x plus y equal to root 2 is our tangent plane. Okay. Actually, we know that we know that parametric equation. Since this is the linear equation, let's find the parametric equation of the tangent plane. So let's think about the parametric equation of the tangent plane. Actually, it'll be given by S and T, and one point was 2, 5. It is given point, and okay, it is given point, and we need to find the two vector, but it is TU and it is TV. Actually, we find these two vectors. So at previous page here, you can see that TU and TV is given by like this. So let's copy and paste here. But you know, we want to find the tangent vectors at U is pi over 4. So our TU at one point is given by minus 2 times pi over sine pi over 4. It'll be, you know, root 2 over 2, 2 times root 2 over 2, comma 0. And TV is not dependent U and V, so it'll be just the 0, 0, 1. Okay. Since there is no space, let's think about it. Just a minute. It is red one. And move here. Okay. Then our parametric equation is given by root 2, 5 plus s times our tu is given by minus root 2 plus root 2 and 0 plus t times 0, 0, 1. Okay, then it'll be root 2 minus s root 2 and root 2 minus s root 2 and 5 plus t. Okay, this is the also the tangent plane at our given point. But it is the parametric equation, so it is given by s and t. Okay. So you know, as you can see, if x plus y, if you calculate the x plus y, it'll be 2 times root 2, right? This is the same equation here. Okay. Just a minute. Here, TV 0, 0, Okay. Okay. So we find the parametric equation of the tangent plane here. Okay, cool. And okay, this is the last problem. And actually, I will record one more video, and at the video, I will review all concepts and problems we talked about before to prepare the midterm exam. Okay. Okay, I will stop here.